Good morning, everyone. Welcome to Superelevation, Demystify the Superelevation Wizard. My name is Scott Wendt, and today I'll be taking you through the process of adding superelevation to alignments using the Superelevation Wizard in Civil 3D. Before I begin, here's a little bit about myself. I graduated from Marquette in 2015. I'm a transportation engineer at Jacobs and have been with Jacobs for 10 years, with 3 of those years as a co-op student at Marquette. In my time with Jacobs, I have worked on projects of different sizes and complexities that have all used Civil 3D as the design platform. And I've designed superelevation for alignments using different roadway types, design speeds, and design criteria. So a couple things I hope you learned today. First, how to define superelevation and how it's applied. Second, how superelevation is designed and controlled using the Superelevation Wizard in Civil 3D. And third, how to validate that the design is correct and applied properly in our corridor model. So before we get through all our calculations, take a step back. What is superelevation? Well, it's defined as the rotation of our roadway cross section to overcome the force that acts on a vehicle traveling around a curve. Superelevation is important as it helps our drivers on our roadway navigate our curve and to not drive off the curve. As we're going through some of our calculations, you're going to see a lot of these terms today. First is our normal crown. That's the typical cross slope of our roadway section, as seen here in section AA. Our level crown, where our rotated portion of our roadway is flat at 0%, as shown in here section BB. Our reverse crown, where our rotated section is now equal in slope, opposite in value, as shown in section CC. And our full super, where our roadway has rotated and is at a full superelevation value. We'll also see our tangent runout, and that's the distance it takes for our roadway to rotate from normal crown to level crown, and our runoff length, which is the distance our roadway rotates from our level crown to full superelevation. Our superelevation transition is the sum of our tangent runout and runoff length. And as we're going through some of our calculations, we may see a normal shoulder station. So if our shoulder and our lane are at different cross slopes, our shoulder is going to rotate up to match our lane cross slope, and then they'll rotate together to our superelevated cross slope. We may also see our low shoulder match. So if our lane is rotating to a superelevation value that's greater than our shoulder cross slope, when our lane matches our shoulder, they will rotate together to our superelevated cross slope. Now, before we can run through the superelevation wizard, we have a few steps that we have to do first. First, we need an alignment, preferably with at least one curve. The superelevation wizard does not like alignments and will not run the wizard if it does not have a curve, but with a little magic, we can add a user-defined curve and then run our calculations. And I'll go through how to do this later on in the presentation. Next, we want to add our design speeds to our alignment. We can have one or more design speeds. This will help to determine some of the values in our calculations. And then last, we're going to select our design criteria that we're going to apply when we run our calculations. So in Civil 3D here, you can see I have a couple alignments created. I have a reverse curve alignment, the corridor applied right now, with a long tangent section in between, so that when our runouts between curves don't overlap. I have a smaller runout section on a reverse curve, and we're going to see how we handle overlapping stations with our superelevation calculations. And then I have our straight alignment. So for our first alignment, we're going to select it and go to the alignment properties. In our design criteria tab, we're going to see we have our design speeds and the criteria that we're going to use. So you can see here I've added 2 design speeds at starting at stations on the alignment. If we want to edit them, simply click in the field and you can type in a new value. Same for our station and design speeds. If we want to add or remove a design speed, there are 2 buttons up here. We're going to add one. It's added at the beginning. We're going to push this to the end. So we are going to click this button, and now we're in our model space, and we can snap or type the station that we want to put it at. I'm going to change the design value to 60, and now that's applied to our alignment. Now we can select the design criteria file that we want to use. you click the three dots on the square. It'll take you to our criteria files, and we can select which one we want to use. For now, we're going to use the WIS.dot criteria file. And then there's a couple more criteria that we can change. We can change our minimum radius table. We'll see the selection that we have here. We're going to use the 6% today. Our transition length, we're going to set this just to the one lane, but there's a couple other options that we can choose. And our attainment method, whether it's a crown or planar roadway. For now, we're going to set it to a crowned. Okay, and now we have those first steps accomplished. So now that we're ready, we can run Superelevation Wizard and calculate our values for our alignment. 4 steps here. First, we're going to select our roadway type. We have undivided and divided, crowned, and planar options. Then depending on those options, we'll have different pivot methods, how we're going to rotate our lanes about the roadway. Next, we have our lane information, how wide our lane is, our lane cross slope for our normal sections, and how many lanes we have. And if we have an asymmetric roadway, we may add 1 or 2 lanes on either side. Next, we're going to add our shoulder information. We're going to add our width and our normal cross slope. And depending on our roadway type, we may be able to calculate the inside median shoulders or outside shoulders. We'll also be able to determine our cross slope control method, so how our shoulder rotates adjacent to our roadway or our lanes. And lastly, we're going to confirm our design criteria. So what we're going to do first is calculate our superelevation for a planar roadway. And this section here will be our example for the first, so 1 lane planar. So if we select our alignment and go up to the superelevation option at the top, I have a couple options here. We're going to select the calculate edit superelevation. We have no data in here now, so we have 2 options. For now, we're going to start with our superelevation wizard. And before we begin, I have 2 notes for superelevation. First, when we're creating superelevation, we want to assign it to our alignment while it's in its base file. If the alignment is data shortcut and there's superelevation in another file, that file will not come with the data shortcut. So best practice is assign your superelevation in your base file, and anytime you data shortcut it, it will come through to that next file. The other thing is if you data shortcut alignment into another file, you'll be able to see the superelevation data, but you will not be able to edit it. So you can only edit that file from where it came from. In this case, it's the base file. So I said we have a couple options here. Right now, we're going to start with the undivided planar. We can select our pivot method, and you'll see we have a couple options here. If we select a different one, the graphic will update to show you where it's going to rotate. For now, we're going to stick with the center baseline. The high side location is with our typical section where our high side is. In this case, our lane slope is going 2% down to the right, so our left side is going to be the high side. We have the options of level and right, but we're going to select the left. So now we'll go to our lane. So first we have our symmetric roadway. If we wanted to uncheck that, on either side we can select whether we have 1 or 2 lanes. For now, I want to keep it symmetric. We have our lane width and normal lane slope. Those values look good, so we're going to keep that for now. Now we have our shoulder slope, and you see we cannot calculate our inside median, but we can calculate the outside. So we're going to keep it at 5 feet for the width, and for the shoulder slope, we're going to match our lane, 2%. You also see that we cannot edit anything for our planar roadway for our shoulder slope treatment. We select different roadway types. We have a couple options that we can select. And then lastly is our design criteria. So we're going to click this box and then browse to our design criteria files. Again, we're going to double check we have the right one. Our superelevation rate, we're going to stick with the 6%. We have a couple other options that you can change in your calculations. Our transition table is correct with our 1 lane ramp. And then we're going to change this back to our planar roadway. Now you'll also see we have a couple other options here. First, we can select the percentage of our runoff that we want on our tangent or our spiral and our tangent curve or spiral curve locations. For now, I'm not going to modify these values, but we can always change these when we do our calculations. A curve smoothing, if this is selected and given a length, at our transition locations, instead of an abrupt change, it'll add a vertical curve to our slope profile. And then lastly, if we have areas that we know we're going to have overlapping stations of superelevation, if we select this value, it will remove any stations that are overlapping and then connect between what's remaining. So for now, we're going to click finish and check our values of superelevation that we see. So the first thing it opens up is our tabular editor. This is going to show all the information that we have here. I'm going to take a quick peek to make sure we have all the correct stations, and those look good. And then we're going to take a look at our values, and we've got our roadway is planar and rotating up 6%, and then it's planar and rotating down and then back up to our 4% in the opposite direction for our curve. So now that we have our superelevation updated, we're going to rebuild our corridor, and we're going to step through the corridor section editor to check our model. So I'm right here in the middle of the curve, and two cool tips that you can utilize here. If you select in the tabular editor, if you select your curve, it will highlight it. So you'll see curve 1 is highlighted for down here. If I go to curve 2, highlights it up here. So that's a useful tool if you have multiple curves to figure out where you are. As well as you click any of your critical stations, you're going to see a blue tick show up in the model space. So as we select our other stations, we'll see that in our model space. Again, another cool tip to help you remember where you are in the model space on your curves. So everything looks good here. Our road is planar and super elevated. We're going to go back to the beginning to see our rotation. And the first thing I notice here is our shoulder slope is rotating down where it should be up. So we're going to keep an eye on that, see if that's happening to our other curve as well. We're going to step through. Our shoulder is rotating. So now we're at 2% planar. So we're going to have to take a look at this area and come up with a picture of that. Now we see our shoulders rotating. Now we're at our full super station. That matches. And then we're rotating back out to our normal crown. So now that we have our normal crown stations, there should be no rotation. Let's step through a few stations and double check that, and that looks good. Now we'll fast forward to our next critical station. Here's our end normal crown. Step through and see the rotation as it rotates to 4.5%. It's planar. We're through the curve. So now we'll see the run out. And it's rotating back to our normal crown. So here we are at our begin normal crown. So let's see between this station here and the endpoint, if it's going to rotate our shoulder back. And it is. So what's happening here is when we did our normals or our super elevation calculations to show you what options we selected. In our shoulder control, we said our normal shoulder slope was 2%. So whether it's left or right side, it's going to go 2% down. Now, that's going to be at our beginning alignment. That's going to show up as our cross section or our slopes. We look at our normal crown and we're opposite. So when it's rotating in between. It sees some rotation. So one way that we can fix that is adding some manual stations in there. So I'm going to select my first curve, add a station up here at the top, select the station and see what values it gives. And we can see here the outside shoulder is at 2% down, so we're going to change that. When we're in our tabular editor, any of this data in these white boxes we can change, we can select and manually type in the data. The station's the same thing as well, as you can select this options and choose and snap to a station in the model space. So we fix the front there. Let's add a station at the end. One thing to note, if you add a station outside of your curve region, you're going to get a warning error in the overlap. So you always want to make sure that you select your correct curve when you add your station. We're going to see what's going on at the end here, if it's doing the same thing. And here's a good example of some issues that you may encounter as you're working through. Sometimes when you're working in your tabular editor, you may change some data and it may not show a change. So what's going to happen is type in your data like you will in our manual station. There's nothing showing up here. I'm going to type in my data. Still not showing up. One way to fix this is to simply close the tabular editor and then open it up again. You see here as I went through and changed more data, now it showed up. I'm going to close this and make sure everything is changed and been added how I wanted. That's something that I've noticed very common is you'll have these visual issues. The first station looks good, where you change data, it seems like it does not change. You close the editor, reopen, and your change is added. So now we've added these normal stations that are begin and end. Going to rebuild our alignment, our corridor, and see if our slopes have updated. And our end station looks good. Let's step back. There's no rotation, so let's go to the beginning of our alignment. That looks good too. And then let's step through this. That is also good. So that's the first run through of how to calculate super elevation. Now let's talk about how we edit existing data that's there. So we have a couple options when we're modifying our existing elevation data, super elevation data. First, we can delete it or rerun our super elevation calculations for the entire alignment, and we'll overwrite what's there. Another option is we can use the curve editor and change data for separate curves and then recalculate it for that curve only using that new data. We saw in the tabular editor, we can modify what's in there. We can change the station values or cross slopes. We can add or remove stations from the tabular editor. And then we can also, if we have a lot of stations that we need to change or a lot of data that we need to add or remove, we can export that data to Excel, update it in Excel, and then re-import it to our alignment. So let's run through this alignment and recalculate it as a crown roadway. So you see here, this is the curve editor. We're going to use that in a bit to add some properties after we run our crown section, but we're going to recalculate it for the entire alignment. We have some manual edits. It's asking if we want to override it. We're going to say yes. So now we're going to use the undivided crown. You see, we just have the pivot method here that we can modify. Again, if you change these options, your picture will change to tell you where you're rotating about. For now, we're going to keep the center baseline. We're going to go to our lanes. Still going to be a 2-lane roadway, so one road or lane on either side of the road. Slopes and lanes look good. Still cannot calculate the inside, but we can have the outside that we can change. Our normal slope, we can change to 4% now. We see that we have treatment methods that we can choose for our low side and high side. So if we choose our default slope, it's going to keep this normal shoulder slope on the low side. If we match our lanes, it's going to rotate to match it and always stay at that lane slope. And then if we have a breakover removal, what's going to happen is when our lane rotates past our shoulder, it's going to then rotate together so that we don't have a lane or a cross slope break between our lane and shoulder. For now, we're going to use our default slopes. On our high side, we can match our lane slopes or use our default slopes. If we choose default, we now have an option for a maximum shoulder rollover value. So the algebraic difference between the lane and the shoulder, if we set it, will not be greater than this percentage, and our shoulder will roll up. For now, we're not going to use that. And then lastly, we're going to check our design criteria. Not much has changed, so we're going to finish and look at our data. One quick check of our data. It looks like a crowned roadway. To start, we're going to have our left side and right side rotate on the respective curves 1 and 2. Our shoulders are staying the same. So now let's rebuild our corridor with our crown section. With our new data and check our model. I'm in a transition reading here. I'm going to go to the beginning and then step through this first curve. So the normal section looks right. Our lanes are at 2%. Our shoulders at 4. Let's step up to our normal crown and see as our left side rotates. So it should just be the left lane rotating up to 6%. Now our right lane's rotating with it, and we're in our full super. See our transition out. Both lanes rotating, level crown now, and back to normal crown. So our first curve looks good. Our road was rotating to our super elevation values that we set. Our shoulders stayed at the default slopes. So let's go to our second curve and see how we rotate through that curve and check that everything looks right. Here's our normal crown, and now our right side's rotating, or reverse crown, and the lanes are rotating to our super elevated values. Our shoulders are staying at the 4%. And let's check our exit from the curve and the runoff. 2 RPM. Now we see our roads rotating back towards normal crown. There's no rotations that we weren't expecting, and everything looks good. Now, one thing that you may want is in our super elevated sections, we want to make our shoulders match the cross slope as we're rotating past. That's that low shoulder match. Or we want to add that high side shoulder rollover so we don't violate any design criteria that we have. We're going to add that now. We're going to select our alignment, and we're going to calculate it for our individual curves. So you can see here, we can step through the curves, or we can select them in a drop down. You can see the data that we can edit here. Some of it's grayed out as a function of the geometry. But down here in the super elevation criteria, we can change what we want. For now, we're going to just check our shoulders. The high side, okay, the default slope, we're going to keep that. And we have our shoulder rollover value. Now on the low side, we're going to change that to add our breakover removal. And you'll see if you change anything in here, now it will show it's out of date for your curve. You click recalculate, it will update our values and show us it up to date. So now I'm going to step to our next curve. We're going to change our low side as well, recalculate. Now we're going to look at our tabular editor. We'll see now that it's added a low shoulder match station. So our roadway is rotating how it would before, and now our shoulder on our low side, which is the right side on our first curve, is rotating to match our percentage. See though that our high side shoulder in this location did not rotate for our breakover. So I'll talk about that here in a second of why it did not do that. Let's check our second curve. The left side is going to be our low, and it's rotating our lane. Outside also did not add our breakover slope. So talk about how we fix that. Let's just check our model to rebuild it to see that our our low side shoulders are rotating with our lanes for that shoulder match. Check our first curve. It's our level crown. Let's step through. We're at our shoulder match station now. We should see our low side shoulder rotate down. Good. That's acting how we want. High side is doing what our super elevation is telling it to, but it's not what we wanted. So we're gonna have to go back and fix that. Let's check our run out from the curve. And there we go. It's rotating with the lane. It's matching, and now it's at its default value. So let's check curve 2. And step through this first part to see if our low side shoulder is rotating. Now we're at our low shoulder match. Should see our low side shoulder rotate, and it did. And again, our high side's not, so we're gonna have to fix that. Let's check the exit off of curve 2. Our shoulder does match super elevation. That's good. And let's see that it rotates. Oh, and it does. My side did not rotate, so we're going to have to fix that. So one thing that happened was when we went through our calculations and calculated the super elevation, we did not select that breakover percentage. So that's why when we recalced it for the individual curve, it did not do that, is because it wasn't selected before. So if we need to redo that option, the best way to do that is to recalculate it for your curve or the entire alignment using the wizard. So now these values should be the same, so we can quickly check, just make sure they are the same. We're going to reselect, we're going to select the maximum shoulder rollover at 8%, so we should see our shoulders rotate. Double check that looks good, and now we're going to check our super elevation. So looking at our shoulders here in the first curve, now we see that we are rolling up our shoulders. It's added a new station, begin shoulder rollover. Check the exit, and it's also rotating. And I'll check our second curve. Now we're rotating over here on the right side, and it's rotating so it doesn't break. So another way to fix that is rerunning it through the wizard. Now, if we look closely here, we see at this begin shoulder rollover station that it's added, it's changed our outside shoulders value. So it should be at 4%, and put it at 2. It's the reason why we should always be diligent in checking what the super elevation wizard gives us, because it does make mistakes like this. So we're going to edit these so it's at 4% as it should, and it's not rotating to 2. And it's done it at all 4 stations here, so we're going to recheck these. Now another way, since if you look at these 2 shoulder stations or shoulder critical stations are at the same station, we could select them, and up here at the top, when you have it selected, you click the red X, it will remove that station. That's something else we can do in the tabular editor. For now, I'm just going to fix our value. Quick double check, make sure everything looks good. And it does on curve 2 and on curve 1. So now let's step back to the beginning of our alignment, rebuild it, and then check that our high side is rotating. So let's bring up the tabular editor again. Got curve 1. And now we're rotating through the curve. So when we get to our super elevation, we should see our super elevated section, we should see our high side start to rotate. Double check our low side rotates as well, and our high side's now rotated. So by checking that option and adding our break rollover value, it is now rotated the high side, and it's doing what we want. And on the exit of the curve, it does that too. Hit normal crown, looks good. So let's hop to curve 2 and check that our values are being added to our model. normal crown, we should see our low shoulder match the lane at 4.5%. On our high side should be a breakover at 3.5. For our matching stations, for the next one, we should see rotation, and we do. It's holding it through the curve. Let's check the exit. This is at our end full super station. Should be rotating down, both of them do, and now they're holding their 4% values. It rotates moving the crown. Perfect. So that is how we can recalculate them using the wizard. We did it for the whole alignment, but you can use the wizard for individual curves, or you can use the curve editor and edit the values in there. In the tabular editor, I showed that you can add or remove stations. You can change the values, the cross slopes in the stations. Another thing that you can do if you add a station is you can assign it a critical value. Like we saw there, we had the normal crowns. And when we add a new station, it'll be a manual station. You right click and go to assign critical station. You have this list that you can choose from. Take note though, was once you assign it a critical station name, you cannot change it, and it'll show up as these where you cannot change the name. So if you assign the wrong name, then you have to remove the station and then re-edit the station. Now, one other way that we can edit data is to export it to Excel. So up at the top here, you'll see this option to export the Superelevation data. It'll open up a window of where we want to save it as. So we're going to select and save. Hit yes. Now I'm going to open up that Excel spreadsheet. And then we can edit data in Excel and then re-import it. So I can see here the values look similar to the tabular editor. We can see we had that issue before with the begin alignment. This was set at a different value. So we can export it, change that value, re-import it. That will also fix it. But for now, to see some changes, we're just going to change these shoulder slopes, re-import it, and then check that it worked. The easy way is just to change these slopes and re-import it to show that it works. Up here next to the export is the import. I'm going to ask you to browse to your file, select it, and open it. Ask you if you want to override it. We're going to say yes. We should see our outside shoulders now been changed 3%, which is what we did there. So there's another way that we can edit data. It's very useful if we've got a lot of stations that we need to change. And it's a lot easier than using the tabular editor. So another great tool for Superelevation is creating the Superelevation view. This is an easy way to visualize our transitions. There's a lot of labels in there that tell us where we're at, what stations we're at, our values. We can also, in the profile view, edit the values. We can edit our stations. We can edit our slopes. We can change the distance of our runout or runoff lengths. And in general, it just provides a good visual check of our design. If our profile is jumping all over the place, we're going to be able to see that and know that something wrong is happening. Or we can assign design checks, and we'll have warning symbols saying that our design checks have been violated. We're rotating too quickly. Our slope is too big. We're going to roll over, or we have the overlapping stations. So what we're going to do is calculate Superelevation for this reverse curve and see how we handle creating a Superelevation view as well as the overlapping stations. And there's no data. We're going to use the wizard. We're going to just use basic information. We're going to treat this as a crowned roadway, one lane. Our shoulders are just going to be set to the default. Double check these values. We're going to uncheck this, and we'll come back and redo it, rerun it to automatically resolve our overlaps, but for now, I want to show you what it'll look like in our super elevation view. Now, when you get our tabular editor, you're going to see we've got these overlap warnings. So if we select it, it'll give you the option to resolve it here or ignore it. We're going to resolve it when we recalculate it. So you can see we've got stations that are going past on curve 1 that are going past the stations on curve 2. So we're going to create our super elevation view. We select it up here at super elevation. Now we can select the super elevation view. Again, you can give it a name, select our alignment, select the layer that we want to bring on. If you have certain styles created, you can apply these. If you've got a long alignment, you can use a specific range. You can cut multiple super elevation views. And then depending on how we calculate super elevation, we have all these options of our lanes. So if we have median, a divided crown with median, we're going to have inside and outside shoulders and lanes. But for this crown, we just have the lanes and shoulders, the left and right side. I'm going to set them to some other colors so that we can differentiate what is what. And then once we're done with that, we can hit OK, and it's going to ask us to place it in our model space. So now we can see we've got a warning symbol here. Something's going on, but we can see our lane slopes rotating. So if we hover over it, it'll tell you which lane we have. This is our outside lane. If you select it, you'll see a bunch of grips come up. And if you hover over each grip, it'll tell you what you can do. If you want to move it, this is the normal crown. If you want to remove it or add another station, if it's gray, we may only have one option, and it's tied to something else. So be wary of that. Again, we can change multiple values here. We can remove the gray break or add curve smoothing. I'll show you what the curve smoothing looks like. We hit that. Again, it was at 50, so it's a short curve. You select your value, which we don't want to change the slope value. And now we have a smooth vertical curve in that gray break. Just going to remove it now. Anything that you can do, you can undo pretty easily. So again, we go over our super elevation view. We've got this warning sign. It's going to tell us curve 1 overlaps with curve 2, and we've got something going on with all these stations. So if you hold control and select on a profile, you'll be able to just modify that profile. And you'll see it goes from our super to our run out, and then back, and then it's running out to other ones. So when we go through and recalculate it, it should remove these, and it's going to connect the dots between super and super since these all overlap. So we're going to select that alignment, quickly run through our properties. These haven't changed, so they're all good. And then we're going to, in here, check automatically resolve our overlap. So you can see in our tabular editor that there's no more stations between our super. So it's rotating from one value to the other. And that's how it's going to look. A lot cleaner. May not be exactly how our design wants, but it's a good step for our design. Now you see we still have a warning sign here, and it's the design check is violated. Based off the default design checks that we had, we are rotating faster than we're allowed. So this will show up if that is happening in any location. In this case, we may have to move our stations back so our rotation fits within the distance from full super to full super. Now, another thing I wanted to touch on is when we are creating our corridors, we want to be aware of how we designed our super elevation. So when we did our one lane crowns or planar roadway, we only had outside lanes and outside shoulders. If the parameter of this lane was set to the inside lane, it would read no value that's there and then use the default crosslope that we have assigned to it. So you want to make sure that our parameters that read super elevation are set correctly to how our super elevation was designed. So I have a couple options here of how we would set our parameters. You can see in this one lane road, we don't have a lane to the left, just a shoulder. So when we run through our calculations, we'll have information for that left lane, but we don't need it. Our outside lane and outside shoulders will be set for our left and right for this assembly. For our 2-lane road, crown or planar, this is how it's going to look. Pretty much the same thing as how our one lane planar was calculated. And this will be how our parameters will be set up to read our superelevation correctly. Now, there may be a separate case, and I'll hold these in the same view, for example, of where we have our crown is offset from our reference line. So we want our inside and outside lanes to rotate separately. In this case, we want to calculate it using that divided crown, and we'll have an inside and outside lane that are rotating opposite of, or not rotating the same. So we may have our inside lane rotating, our outside staying, or opposite, or vice versa of that. And again, in this case, we might have some information on our left side, but we're not using it, and that's okay. There's a 4-lane crown or planar. And again, depending on how we calculate it, if our inside lanes are rotating and our outside are not, we're going to make sure that these 2 lanes are set to read that. If our inside and outside lanes are rotating at the same percentage and are set to the same cross slope, then we can have them as an inside or outside lane, depending on how we calculate our superelevation. So again, you want to make sure that you're aware of how you're setting up your corridor, your assemblies and your corridors in respect to your superelevation data to make sure it reads it correctly. Then lastly, we have an alignment that's controlling a divided crown. In this case, there's no median, but we'd run it that way. And our inside lanes would be controlling our right, on our right would be controlling these 2 lanes and rotating separate or different than our outside lanes. And they have different slope values. Also, when we're doing this, the left and right would be controlling separate roadways. So our right would be controlling this roadway and our left would be controlling this. So more complicated example, we'll walk through that quickly and create some superelevation for that, but you really want to be aware of how you're calculating it. You also see our inside shoulders are going to have different values than our outside. So I talked about that second one there. We also have an example of an alignment without curves and how we add that data. I'm going to hop back to this and add data to our straight alignment. So when we select our alignment to add superelevation, we go up to our calculate. It has no curves on there, and you're going to see that. So it does not calculate any data. We're going to go to our tabular editor. We see that there's no curves and no data. But if we go back to hit our calculate edit superelevation and open our curve manager, again, we're going to see we've got no curves in here. But if we select the create user defined curve, now we'll get a prompt to select entities to create a curve. In this case, we just have the alignment. Hit enter. In this case, I've got a visual issue. Where I cannot select my alignment, but I'm going to add one to this curve to show you how to create a user-defined curve. We create this user-defined curve, select the first part of our alignment, hit enter. Now we've got a user-defined curve with no radius. Check our tabular editor. We'll see that show up. And here, and now if we run through our calculations again, it will add that information to our user-defined curve. One thing to note, since there's no curve radius, we're going to get a couple errors saying that we do not meet the minimum criteria for a curve radius, but it will give us superelevation still. It will, with that, it will also give the maximum superelevation for that table. So if we're using 6%, it'll go at 6%. My suggestion is take that data, export it to Excel, add or remove stations and modify your data as you need, and then re-import it. But that's how we're going to get superelevation data on a linear alignment with no curves. So the other example I talked about was creating superelevation for a divided crown with the median. So we're going to run through our wizard quickly. as a divided crown. We'll see that we have different pivot methods, and based off what we choose, we can have a median treatment. What that's going to determine is whether our median stays the same shape or it's distorted vertically. So again, for this, we're going to keep our centers where we're rotating about. Our lanes and shoulders, we're going to set them to be defaults. Well, now we can see we can calculate our inside median. So if we hit calculate, we've got our default slopes. Check our attainment or design criteria. We want our 4-lane undivided median and hit finish. Now we're going to see we've got left outside and inside shoulders and lanes. Slopes look pretty good. Let's update our corridor and double check. Normal. Slopes look good. Let's just step to that first curve and double check everything's rotating. See our left side rotating and now the right side. And it's rotating planar. Our shoulders, we didn't keep any values, so they're right there, more values, and that's going to look exactly how I would expect. Let's double check the runoff. And we're back to normal. Wonderful. So that would be an example of how you would do a roadway, 2 separate roadways with the median. So again, some of these issues we encountered, visual issues within the tabular editor. Simple way to fix that is to input your data, close it, open it, and check that everything has been edited correctly. Now we might have some wrong slopes at critical stations. It's not perfect in the calculations. We want to make sure we're diligent, checking all our values in the tabular editor. And lastly, corridor interpolating cross slopes. You saw that example where the begin and end stations, the normal cross slope was different than our first end normal crown, begin normal crown. So we can fix that by adding a manual station or exporting our data to Excel, editing that data and re-importing it. So in summary, Civil 3D provides a great tool to calculate superelevation. It's not perfect. We need to make sure that we check our information to make sure everything is correct. There's numerous inputs used to determine superelevation. Design speed, design criteria, roadway type, pivot method, and curve radii all affect our calculations. Multiple ways to modify existing superelevation. We can recalculate it for the entire alignment or individual curves and overwrite what's there. We can manually edit in the tabular editor. We can export it to Excel, modify it and bring it back in, or we can modify our values in the superelevation view. And lastly, there's several design checks. We're going to get warning signs based off our design checks in our tabular editor. Visually, we can check it in the superelevation view. Well, there's going to be warning symbols of design checks or overlapping stations. And we can also check within our corridor to make sure if it's set up correctly, it reads the superelevation and it's doing what our design is supposed to. So thank you all for listening to me today. I want to say thank you to all my Jacobs colleagues for helping provide material and Kyle Peschel for the awesome name for this presentation. With that, again, thank you for your time, and I'll open up the last few minutes for any questions you may have.